kids, Miss Kulkarni here. In this video, let's talk about food calories and how do we calculate those food calories. But before that, we need to know what is a calorimeter and how can we use it for finding the food calories. Now these are two pictures for the calorimeters. One is the complex one which we use in industry, and one is the simple one which we may use in our labs. Both the calorimeters have same function. There is a small container where we can hold food particle, and that food is burnt, and as the food is burnt, water is allowed to heat, and we measure the initial and final temperature of water, and based upon those calculations we find out food calories. Let's actually work on some calculations. So once again, the basic idea of a calorimeter is capturing the released amount of heat, and then that is used for increasing the temperature of water. Now we make one assumption in this process, that the heat which is given out by the burning sample will be only absorbed by water. There is no heat which is going to be lost to some other sources. So basically we are going to say heat loss is equal to heat gain. Heat is lost by the chemical reaction or the process, and heat is gained by water. So that's the formula. Heat lost by the process equals heat gained by water. And how do we calculate heat lost or heat gain? That is the formula which is MCAT formula. It is in fact mass times specific heat C and delta T, which kind of looks like M and CAT. So let's look at our first problem. We are in fact burning sucrose. That's the amount of sucrose which we are burning, 0.303, and that's the formula for sucrose. And then in the calorimeter we have 240 grams of water, and these are the temperatures given, initial and final temperatures for water. So using this information, our goal is to find out the heat change for sugar. But wait a second, we know that heat loss is equal to heat gain. So let's actually find out heat gain by water. And the formula which we are going to use is MCAT. So MC delta T. What is the mass of water? That is 240 grams. C for water is 4.184. And delta T will be final minus initial. So that makes it 27.55 minus 22.53. And when we work on the calculations, what do we get? We get 5040 joules. Now this is amount of heat which is gained by water. So sugar will be the one which will be losing that heat. So Q for sugar will be exactly same value except opposite sign. So it's negative 5040 joules. Alright, we got heat generated by burning sugar. Now our next job is to calculate food calories. So let's work on that calculation. But before that, look at these two conversion equations. We are going to use those. And from previous problems, we know the amount of heat was 5040 joules. We are going to use that. Let's get some dimensional analysis. That's our beginning value. And now from joules, you're going to go to calories, and from calories, we can go to food calories. So once we got our roadmap, we can put the values here and try to cancel the units crisscross, and then plug the values from the equations here. So joules and calories. Calories is 1 and joules is 4.184. Food calories is 1 and heat calories are 1000. When we solve this, what do we get? We get the final amount of food calories, which is 1.20. So this is a simple method of calculating food calories for any given substance. Alright, in this problem, we are going to move to the next step and we are going to find heat of combustion of sucrose in kilojoules per mole. So this is on sucrose, 0.303 gram. Just to remind you, we got negative 5040 joules by burning 0.303 grams of sugar. And we need to convert that to kilojoules per mole. So how do we convert that? First of all, N, number of moles, is mass divided by molar mass. So sugar is 0.303 grams. And the molar mass for sugar, the formula is C12H22O11, and the molar mass for that comes out to be 342.22. When we solve that, the answer is 8.85 times 10 to negative 4. So many moles. Now this is in joules and we want kilojoules. Now if you divide the amount of heat by the moles, we are getting joules per mole. But the only thing we need to keep in mind is we want our final answer in kilojoules. So we can continue that conversion here from joules to kilojoules. And that's the way we are going to get to kilojoules. And when we solve, what do we get? It is 5.70 times 10 to the third kilojoules per mole. Now look at the next question. It is asking if the heat listed would be a reactant or product. Delta H, which we got, had a negative value. And a negative value indicates heat is release. So if heat is release, it must be exothermic process. And if it is exothermic process, we write the heat on product side. So there we go. We got the answer about how we represent enthalpy. I hope you guys enjoyed the video and I'll see you again in next video. Until then, bye bye.